And here we go again from worksheet 53, number 1. Now, this is just fun. I like this stuff because it's fun, right? And the reason it's fun is polar, which is super confusing usually, but then as you start to get used to it, it gets more handy. It has an equation for all their conics. It's kind of the same. It's constant E times eccentricity over 1, and then there's either a plus or a minus depending on the directrix value. So if you know what a directrix is, you'd be like, oh, that's on the other side of the vertex as the focus, right? And then it has eccentricity here again, and then it has either cosine or sine. I don't know which one, but that just tells me that the directrix is either x equals or y equals. So that's what's neat, is a one formula could have so much info and so many different shapes. And remember, if eccentricity is 1, that's a parabola. And if it's bigger than 1, then it's a hyperbola. If it's less than 1, it's a ellipse. So much going on in one equation. It is gorgeous. So first things first, if somebody gives me an equation like this one, I notice, oh, it's a conic, and I get all excited. But the big problem is that's not a 1 there, and I need a 1. So a quick fix, divide everybody by 5. Why is that legal? Because really, you're multiplying by 1/5 on the top and bottom. And when you multiply by 1/5 on the top and the bottom, you're multiplying by 1, and you haven't changed anything. So if I do that, I get R equals, what was that, 39/5 over 1, yay, minus 13/5, okay, cosine of theta. Now look at how much I know, right? I know the eccentricity is 13/5. So that's greater than 1, or tells me it's a hyperbola, right? I know that it's negative here, and I know it's cosine, right? So I know that it's going to be x equals a negative number for the directrix. Now, the only bad thing is I don't know that number. That number's k, right? Whatever k is, that's what that number is. So let's go up to that numerator and figure it out. Remember, the numerator is k times e is equal to 39/5. That's what the numerator gives me. But wait, I know e is 13/5. So now it looks like that. And you're like, wait, that's not so bad. I could multiply everybody by 5. Sure. You'd have 13k equals 39. You're like, I could divide by 13 and get k equals 3, or however the heck you set it up. But that's what I would have. So now I would have r equals 39. No more 39/5. I'm sorry. 3 for k times 13/5 for the eccentricity over 1 minus 13/5 cosine of theta. And now I could really answer all the questions, right? I could say, oh, look, that's a 3 there, right? And I can even go a step farther. I don't know if I have to or not. But here it is, right? Here is your graph paper. And you know that this has a focus right here, right? The focus is always at the pole. And the directrix was when x equals -3, 2, 3. So it's right here. Now, on a parabola, the vertex is directly in between. Not so true on a hyperbola. So I'm just going to sketch the total sketch, but it looks something like this. So there's kind of a sketch of your graph. And you could type this straight into Desmos and see if it's true. When you do, type in Desmos, type in R equals, and then type in the equation 39 divided by 5 minus cosine. And then when you want theta, just type in the word theta, Theta. And you will hopefully get a graph that looks similar to that. Hope that helps. Did I answer everything? Find the eccentricity, did. Find the equation associated with the directrix, did. X equals -3. With the focus at the origin, okay. Classify, beautiful. Stay happy.